So this will be the first of many other videos explaining how to use your tree identities to simplify or rewrite certain equations. My overall tip is to be comfortable having to backtrack, because there are a lot of ways to go about doing these type of questions, and you can't be the type of person that just stops when things get hard. And if you do that, you'll actually find them pretty fun, actually. So first one is really easy. Just secant x times cosine x. We want to simplify this. Usually when they ask to simplify, they want it as a single trig function or term. So I'm going to start by rewriting into my basic sine and cosine. When in doubt, always write in terms of sine and cosine when you have absolutely nothing else to do. Here, my cosines can cancel out because I have one in the denominator, one in the numerator, connected by multiplication, and I simply get just 1. So really easy, simple example. Next one. A little bit trickier, right? I have a fraction this time, but the thing that should stand out is that I have an identity that I can use here. If you don't know all your identities, refer back to my video I've posted already. Really helpful. So again, I'm just going to rewrite my numerator as a tangent squared, which is the same thing. And then I'm going to break this further down into sine and cosines. So when I do that, I get something that looks like this. And I see again, just like last time, I have a sine on top, a sine on the bottom, connected by multiplication. I get 1 over cosine squared, or just secant squared. Again, notice how in both cases I singled it down from one big series of functions to just a single expression. Last one. This time, I don't have any particular identity sticking out at me. I just have to again go back to my basics, just sines and cosines, and see if that's going to work anything. So here I'm just going to rewrite this. I'm going to take this cotangent off to the side and multiply by 1 over cotangent, which is the same thing. But it tells me here that I have 1 over cotangent. So if I flip that over, it's really tangent, right, instead of 1 over cotangent. So I do that, and I get sine over cosine. Remember, because it's 1 over cotangent, not cotangent. So sine over cosine times secant 1 over cosine times cosecant 1 over sine. My sines here cancel out here and here, and I'm left with cosine theta times cosine, which, just like last time, will be secant squared theta.